So greetings to everyone. Welcome to Datagaps webinar. I'm Pooja Gupta, Growth Marketing Manager at Datagaps, and I would like to thank you all for joining us today. Today in this webinar, we will share how data quality influences the effectiveness of AI models and how the Datagaps DataOps Suite can help you tackle data quality challenges to improve your AI performance. On the panel today, we have Subhanshu Dikshit, our product manager at Datagaps. And here is our agenda for today's webinar. At first, we'll discuss about why data quality is considered a cornerstone for AI. Then thereafter, we'll give a quick overview of Datagaps DataOps Suite and how it can help with data quality monitoring and testing strategies. Next, we will share impact of data quality on AI models. Thereafter, we will discuss about strategies to enhance AI with testing automation using Datagaps DataOps Suite. And in the end, Subhanshu will share industry-known best practices for data integrity and reliability, which will be followed by a demo of Datagaps DataOps Suite. I would also like to share that we have included a couple of polls which will reflect in the middle of the session. And we would request every attendee to share their feedback by answering those poll questions. And now I hand this over to Subhanshu. Subhanshu, stage is all yours.
So let's get started. Firstly, once again, thank you for everyone to join in. And let's get started with the use cases that we want to cover. But of course, before that, I do want to give a brief overview of Datagaps and where exactly we come from. We've been in this industry for over 10 years now. I believe it's closer to 12. And what we have done is that we have created a suite of products which perform end-to-end validation. And this includes everything ranging from validating migration projects, improving the quality of data in traditional pipelines, and of course, creating synthetic data as well. One of the most popular tools that you will associate with our company is the BI Validator, which ensures validation in terms of visual elements, meta report elements, data elements, and a lot more in terms of BI tools like Tableau, Power BI, and so on. And throughout this experience of 10 years, we have encountered a lot of different problems. The first problem statement, as you can imagine, that's ongoing is in terms of migration validation. And how exactly can we create automated solutions for that? These days, the migration problem statement has been altered to consider cross BI use cases as well. And of course, at the advent of Gen AI being introduced a couple of years back, and everyone is on the AI train now, we need to ensure that there are no issues when we discuss an AI pipeline. And I will discuss this in much more detail. Because at the end of the day, any kind of AI or ML system, be it a generative AI system, an LLM-based system, or a typical machine learning model that you might use for a specific use case, all of them work on data. And bad data is definitely going to ruin the model in a lot more ways than than you can think. And that's what I try to cover in this particular deck as well. But again, I just wanted to give a brief overview that we have been in this industry for quite some time, and we've had a lot of experiences with niche problems and industry-specific problems as well across different aspects. And so that's what our background is. Now let's jump into the actual use cases itself. And what I would like to start with is to build a small story here. Well, of course, we all have heard the popular study from Gartner that organizations lose about $13 million every year from poor data quality. And these can come in from a variety of sources. This could be proper system errors. This could be data entry issues, any kind of failed migration. That's pretty high up, as you can see in the list and percentages of use cases. And of course, there could be a lot of other problems as well. And this study comes in from a traditional perspective, that if you're working with data day in and day out, this is something that can affect its quality overall. However, for an AI system, these things are going to be compounded. And that's something that I want to cover in the upcoming slides as well. But just to put things in perspective, this is what poor data quality consists of. This is what the causes of these are. Now, let's look at a next slide, which actually discusses what the effects of these aspects are. Now, garbage in, garbage out is a very popular term used in a lot of machine learning courses as well as in technologies as well, because it kind of deems exactly what the problem statement here is. If you're working with incorrect data, it's going to result in incorrect models and incorrect predictions. Let's discuss on garbage in first. What do we mean by the incorrect data? We discussed that at the start. These are the entry points for these data sets. But now let's discuss what exactly these incorrect data sets compile of. Well, firstly, you could have inaccurate data, meaning that the data set in itself is just deemed or perceived inaccurately. A very simple example for this would be, say, coordinate systems or precision tool sets, where correct conversions have to be done in order to ensure that the corresponding data is being interpreted correctly. Incomplete data, as you can imagine, is incomplete data. In a traditional sense, this would be the auto trimming of an address column resulting in an incomplete address. But in terms of models, this could also be in terms of incomplete data with regards to the number of records that you're trying to cover, or the consistency and the accuracy of the records that you're covering as well in terms of incompleteness. And this, of course, poorly formatted data. Depending on the type of model you're working with, you might be working with a variety of formats. However, poorly formatted here implies that there is inconsistency within these different formats as well. I'm looking at those complex XML, JSON files, which don't really perform a typical traditional flat database system. And instead, you are dealing with a lot of hierarchical data sets and a lot of objects between them. And this usually can cause a lot of issues, as you might have to pull out the information from these specific inaccurate systems inherently. That's one aspect. Biased data is an odd one out in this list so far, because biased data is something that we have to deal with from a non-traditional perspective. I mean, if you look back previously, say you were working on a data pipeline for a supermarket, the data is accurate as it can be. More people buy a particular product. That's not really a bias. That's the truth there. However, when you're trying to train models, at that particular point, it's very important for you to understand that you're working with an inherent biased data set, especially if the questions that you want this particular model to answer don't correlate correctly with the data that you're putting in. That's exactly what the Amazon pointer is in garbage out. That's the other section which we'll come into, and it kind of comes into play there as well. Apart from biased data, we are working with duplicity in our data sets. That's pretty straightforward. No need to have a lot of explanations there. We're working with unstructured data. There can be invalid data points itself, and invalid data is actually a pretty big pointer, as at many points you would like to see not really go ahead with certain records or convert them into specific records that are deemed as a category of records which don't really make a lot of sense in the training data set, depending on the model you're trying to work with. Then there's, of course, inconsistency. Inconsistency is very important, and one of the favorite examples that I have here is in terms of financial systems. Say you're working at an AI model or say an ML model which works on financial systems, but the data set you're interpreting at a global level has different precision units across. Now, these different precision units are going to inherently affect the system unless you ensure that all of these coagulated systems, all these coagulated finances work at the same precision. And that's just one example on how inconsistency within your data sets can handle or corrupt your model itself as a whole. There's, of course, non-conforming data on top of that, and non-conforming data kind of puts in on top of the fact that when you're working with these models, you're never really working with a lot of, say, characters like strings. You're usually going to term or deem them into categorizations. An easy example would be you wouldn't really define genders as, just male or female or any other value type. You would actually define them as categories, 0, 1, 2, and so on. And ensuring that these categories are correctly addressed and correctly defined, and anything outside pertaining categories is caught. That is pretty important because that's going to affect the corresponding model output as well. Then there's, of course, class imbalance, data annotation errors, and migration-induced errors. Out of these three, class imbalance and data annotation are more user-defined because that requires a lot of interpretation of data. The application is going to help you define those as well. And if you're creating a model, this is something that you'll have to work with. But the last one, migration-induced error, is something that a traditional data engineer will be very aware of, but someone who's coming into the field from an ML perspective, where they are preferably just training the data, preferably used to say good data, might not really see. And this comes in handy when we were discussing things like real-time deployment of these models. That's one of the things that I'll be discussing in the upcoming slides as well, which is that, say you're training a model and everything you get is, crisp and perfect, and there are no issues in the data. When you're actually deploying it, it's not the case. Migration-induced errors, as we saw in the very first slide that I was trying to showcase, is one of the main issues for a lot of errors that come in. And the fact of the matter is that you're going to get your data sets coming in from variety of sources, and these variety of sources need to be compiled into one system. We might have to convert databases into files into other file formats, and then combine them together into a DB or into a file format the model can actually ingest. And all these transformations and migration itself has a lot of pain points where data could be incorrectly, say, transformed or incorrectly interpreted as well. And that's one of the things that we'll discuss within our systems. Of course, finally, I've added a small caveat that all of these definitions of what we define as inaccuracy or incomplete are bound to change when you're discussing things from a model's perspective as opposed to discussing things from a traditional perspective where you had sources and then you had transformations and they put them into a BI system and call it a day. So it's not really the same. And so that's why the definitions themselves could be slightly different. And that's something that an end user has to keep track of when they're discussing why they need to improve the quality of data they're working with. That was a bit on the garbage in part. Now let's discuss what the garbage out really means here. And it means as well, if you have any of these problems, and I mean even just a couple of them, it can result in heavy losses for the end user. And I have the next slide which discusses on the losses specifically, but let's just look at a few of these specifications. Well, the first one is from Unity Technologies, where an ad targeting error, and what they were doing at this point was they were using a model to actually define and who to target. And again, this is very common in marketing schemes, as you can imagine, using machine learning models or AI models to define what subsector or what exact demographics they would like to run with. And in this particular place, we see that Unity's model was incorrectly trained. And because it was incorrectly trained, it was kind of spitting out incorrect targeting values itself. So it was basically not doing the demographics that it was supposed to. And this cost the company about $100 million. And that just really puts a heavy number on what these machine learning codes can define. Because at the end of the day, while this is a direct impact on the revenue, retraining the models and rerunning the systems itself is a costly affair. And that's something that anyone who has worked in this particular field is well aware of. The Amazon study is actually much more different, and it's based on bias data and actually more closer to the aspect that the biases that you're working with are going to come into your model as well. And here we had noticed that the actual, and this is not just this is a study that was done on the Amazon's machine learning system to hire employees and candidates. Well, in that particular case, we saw that there any kind of mention of women or say women's chess captain leagues or any kind of other prejudice right there was kind of exacerbated because the data inherently had these biases. And because they had these biases and the model was not trained to work on against the bias, it was trained to work with the bias. The model had this kind of issue with it where it was preferring male candidates over female candidates. And well, this is one of the biggest issues found. Gender bias was not the only thing. It was also the fact that it did not know how to treat candidates with not a lot of specific experience. So where there were a lot of candidates with just say mediocre experience, or just say non-specific would be a better word here, is non-specific experience in general, they would recommend these candidates to every particular job profile. And the reason for this is not really the model, it's the actual data, because the data itself defines what this corresponding resume or what this corresponding system is affecting against. And so that's one of the main differences of a good model versus a bad model. And in most cases, as you will see, and if you actually look at any kind of process of a good model, is the cleansing of data. So that is one of the important aspects of understanding how exactly bad data affects a model with some real life examples as well. This is some studies that we have seen, and these were quite a newsworthy things. Of course, you can Google them for more details if needed. Now I would like to bring up a very important aspect of cost. And here I would like to introduce a very old rule that's present in the data space for quite a while, and that's the 1-10-100 rule. And what this basically defines is that, well, if you catch a data quality issue at the point of entry, say you're working with a file that's coming in daily and you catch that, hey, there's something wrong with this file. The actual cost of this particular issue is just, well, replacing the file. Quite minimal, and that's perfectly fine. However, if this particular issue goes undetected and you kind of find it much later, then it's about 10 times. The reason for 10 times is quite straightforward. You have to rerun the process once the file is actually fixed. However, if this particular issue reaches the end user, and say this can be in a BI system, and of course in our use case here, this can be the output of an ML trained system, or maybe it's the training process itself, it's 100 times more expensive because of all the corresponding business consequences that come with it. There's of course customer dissatisfaction, operational disruptions, and a lot more. This is very extremely true in ML systems. As you can imagine, the models that we work with usually are working on, say, 25, 50 node clusters at many points. And again, just the sheer act of running these clusters itself is quite expensive. And so if there are issues in the data present, and while we're trying to run these prediction models, and there are issues in the bare data itself that we catch later on, it incurs huge amounts of costs. And so that's one of the key things. And one thing I do want to clarify here is that the data quality issues found in the training process will not be the same issues you find when you deploy them. And that's one of the key things that, well, okay, when I was working with the model, when I was training it, I saw that, well, I was facing this issue, say, on a particular geography. There was an issue between urban and rural geographies, and I was trying to make sure that the segregation there or the categorization that there is done correctly. That's fine. But the moment you publish that particular model and now real data is coming in, you see that this was not completely addressed. We had the system to categorize them, but now the categorization itself is inaccurate. Now we are left with a particular system which is going to send out inaccurate categorization because the rule is not working as intended, and the output cannot be trusted. So the 1-10-100 rule definitely applies to ML, and in fact, I would say that it applies much more truly, and the 100 can also be 500 or 1000 in a lot of cases. All right, so now we're at the penultimate slide, and of course, the last slide is where we'll be discussing a lot of the use cases themselves. But one thing I do want to put in, and this is a slide that we put quite often within our systems, and I do want to point out that the typical AI/ML pipelines do not look like this. It's very similar. We have vendors from a different source. There's a lot of transformation that's happening. There's also a lot of production data warehousing that we do before we push things into analytics. But this is not what a typical system looks like. And so what I'm going to do is I'm going to rearrange this particular diagram and show where exactly we come in that particular diagram. So let's skip that for now. All right. So let's start with a particular process of training a model and the issues that are going to come in and how exactly we can resolve this. The first thing to do, of course, is to show, well, that the application can handle a variety of sources. And that's something that's going to happen inherently. You're going to work with a lot of different data sources. So it's very important for the application to also work with that. What we're going to do here is, depending on the one-time on cadence refresh, I'll come to this shortly, is of course ingest them. So the first aspect is you're going to take in data sources coming in from a variety of systems and ingest them into one specific system. Here is where migration induced errors can come in, and here is where migration validation is a critical use case. Main aspect here is that, as you can see, we're working with a variety of formats, variety of vendors, and if you would like to ensure that these are being combined correctly, that these are being migrated correctly, ensuring a full data comparison between the two is critical. This will come in handy when we discuss the cadence-based refresh as well. But here itself, the first step to do is to ensure that the migration is happening correctly. The next step is, of course, as you can imagine, to analyze the data. Now, when you want to analyze the data, you want to understand what are the different categorizations you would like to go ahead with. You'd also like to understand what you want to define as an acceptable value and an unacceptable value. At this point, any kind of profiling and analysis of the data set that you're working with is very helpful. Of course, an end data scientist is going to look at the data sets more closely, but a preliminary check that the application can provide is very helpful as well. And so profiling and analysis is another place where you would like to define any kind of quality checks. The next step is, of course, cleansing. Well, now that you have found the corresponding issues and you have defined what an acceptable value is and what an unacceptable value is, only thing left at this point is to find them and in many cases fix the records as well. Now this could be based on rules, this could be based on finding outliers, this could be based on defining your categories, and if anything is outside that category, either fixing it or removing it from your dataset itself. And that's where analysis and rules comes into play. Here's where analysis is not used just for defining these systems, but it's actively run on the data sets, regardless of how big your data set is, to make sure that the training data that you're going to put in, training and testing data, is accurate and it can be actually used in accordance to the expected values. The final step here is, of course, data validation. Now, there's a good question here. Well, I just cleansed my data. Why do I have to validate it again? Well, the main aspect here is validation is pretty important, as the model training process itself does not exactly tell you if the ingested file is that incorrect. Let's pick up an example here. If I'm working with a file which is expecting few categories and there is a value, say -1 in there, when I was expecting only 0 to 10 values there. At that particular point, many models are going to ensure that, yes, I'm working with, say, numbers at this point. It could also be 0 instead of -1. But 0 is an unacceptable value according to my system. But the ML model might just pick it up and train itself on that. And now you have some outliers present for model 0, and these records are incorrectly trained on. And so validation is important to ensure that if there are any incorrect records, you find them, and the definition of a correct and incorrect record is entirely based on the context of the model being trained on. Once you've done all of this, well, this is all deemed as part of the data massaging and preparation steps as well. And what you do at this point is now you have the training and testing files ready. If you would like to, you can have one more sanitization round. This is important. And if you're working with pickle files and other systems, again, it's still important to ensure that these files are in the expected format, especially if you're working with really large volumes and if the model training process itself is going to be quite heavy. So it's very helpful for you to define the rules right there and run validations on this one last time. And at this point, you start your model training process. The exact model training process is something we won't touch base on, as this is outside the scope of the data quality aspect. But after this particular model training process is done, once you're happy with the results that you have your trained model. That's all fine and good. So at this point, well, we have done a one-time refresh, depending on how often you actually retrain your models. It's a one-time refresh done. And here itself, we have defined multiple points of failure or multiple points of issues, which can incur a lot of cost and overhead as an end user. So our developer has now created the trained model, but this, of course, as you can imagine, is just one part of the story. Yes, developing a model can also take a good amount of time, but once the model is deployed, now the end user has to actually use it. And this is where real problems come in as well. It's going to be very similar to what we do in our training process, and that's going to be our model usage process, where yes, instead of a one-time refresh, now you're working at an ingestion layer, which is going to work, say, on a daily basis or a weekly basis or even a monthly basis, depending on your cadence. But now the main aspect is, well, this is refreshing data. This is going to come in and day out. Someone might just change the maximum amount of, say, length or column width for address now from 20 to 35. And now your ingestion layer should be able to handle it. If you have auto ingestion switched on, or if there's some auto trimming that's working inherently, now you're going to work with inaccurate data from the ingestion layer itself because of, once again, migration induced errors. That's one thing. Then, of course, instead of doing an analysis at this point, what you will jump straight into is the cleansing, given that you have already defined this data set and you have a good idea of what the expected rule sets are. So once again, a good part here is that if you're working with a system that can easily transfer rules from one system to the other, it's very helpful. And so that's the expectation here is that, well, the data cleansing takes place automatically at a cadence interval where we find out issues and fix any kind of non-standardization that is found in the data set, regardless of the volume of data. And that's a critical thing because at some points you might be working with, say, 100K records, and at other points you might be working with 1 million records as well, depending entirely on your use case. But cleansing is pretty important. After cleansing, the other thing that we have to look into once again is data validation. Just because we have cleaned the data once does not mean that it's actually completely accurate. There's a good amount of profiling that you have to do here. You need to ensure that all the data sets that you're working with are exactly correct, once again, in the context of the AI. So if I'm not expecting 0 in a numeric column, that should not be present here. And if it's present as 0, maybe I've defined another rule set for it, so it should be reconciled into the expected values as well. And that's why data validation is once again a critical part of the system. Once we have done this, we have model-ready files. This could be the pickle files that are prepared within your Python script or any other scripts that you're working with, or say you're using an AWS or Azure-based system. You do see these files from time to time before they are ingested by the model. Before those 50 node systems or those 25 node systems are actually going to run the model in. Now, it depends entirely on the confidence of the end user here, but as I have personally also dealt with a lot of AI/ML pipelines, I believe that these model files should go through at least a routine check, especially on the fact that its expectations are having no strings, maybe working only strictly in numerics, having expected precision in some columns and not in the other, and so on and so forth. These type of validations are going to help you save a lot of time, because at this point, if there are some issues, you will have to rerun the model. So it's going to cost a lot. So it's much easier for you to run one final check on the model ready file as well, regardless of whether you have done data validation correctly. And for all of these use cases, the application Datagaps can actually help quite considerably. But the story is not done yet. Yes, we have our model ready files and the application is going to push them to the trained model. They're going to get an output here right there. But of course, there's a critical point missing, which is that, well, our machine learning model has given us an output, but at the end of the day, it's not working on strict logic. It's working on the output of a LLM, or in this case, a machine learning based system itself. Now, this is something that's ignored by a good amount of folks. But let's say, for example, you are working in finance and you have defined a prediction model to basically put stocks in on a particular value that's expected. Now, again, the model has a lot of weight and say in this, and there's a good chunk of it is automated. But what if you have defined guardrails on top of your model which are not working as intended? An example that I can think from my personal experience was in terms of a prediction marketing model that I worked with. So it was a marketing model that predicted engagement points, and many times, well, engagement points come with a budget. You can't really just contact people day in and day out. We don't really have the budget for that. And so now we need to ensure that, yes, while we have defined our guardrails in our configuration and training process, are these guardrails as expected? Do this particular output actually adhere to the expected business rules? Is it exceeding my budget expectations? Is it exceeding other aspects as well? And so here, validation of our output can be done both in terms of analysis as well as rule-based systems. In my experience, we have used rule-based systems and analysis as well. So that's something we can put here as well. But it is critical to make sure we sanitize the output of the model before we push it ahead to the subsequent process, especially when the subsequent process is also automated and can cause a lot of issues from that perspective. So that is basically terms itself as output validation that the application does. Finally, of course, further processing is a block that's deemed to define all those other blocks as well, but it's not done yet, because once we do get this output, something that's done every now and then is the analysis of the output. Now, again, this is a little different from the validation aspect, because the analysis is primarily done to define retraining parameters. Here is where data drift and model drift come into picture as well, because we would like to ensure that any kind of shift in the profile of the data that we were working with is being captured. A very simple example is that, well, if you've created a financial model for 2014, it's not really going to work in 2025. I mean, it's not even going to work in 2016 in a lot of cases, because the profiles and the aggregations, the expected values between the data set you had in 2014 versus the one in 2015 is going to be very varied. And keeping track of the differences between them is something that the application can help with as well, and something that you have to do yourself in terms of model and data drift capture. So yeah, this basically kind of sums up most of the use cases that we deal with. This is a typical AI/ML model pipeline, which works on a cadence of, say, weekly or daily basis. However, as we have segregated them into training and users process, you can define how you would like to use them. Now, in the next few minutes, I'll quickly just switch my screen over to Datagaps application and show a few of these use cases. Of course, the first thing I do want to bring up are the use cases that we've discussed. The first one is with regards to migration validation. Of course, before that, I do want to give a small caveat. The caveat is that the application can be installed directly onto your infrastructure, and the application can be Spark based, both for horizontal scalability and, of course, to be agnostic in terms of the platform you're using it on. Could be AWS, could be Azure, could be Google Cloud, or even bare metal. And the main aspect is that, well, as we discussed, you might be working with a variety of files. The application should have support for all of them. And let's pick up the very first use case, which is, say, migration validation. Here, let's pick up a use case. Let's say that you're working in an Azure-based system and your main database where you want to combine all things together is in Snowflake. And so you have this particular CSV file placed in an ADLS location, and you'd like to ensure that it's being migrated correctly into your Snowflake system. So the application can do all of this inherently. In fact, the test case creation itself can be automated, and the application is not only going to define how many records are matching properly, but it's also going to segregate them into proper data sets. So right now, if I want to go ahead with just the 15K records which are matched, I can do that. If I want to, say, go ahead with this additional set of records that's only in A, which represents the records which did not make it through the migration, I can do that as well. If I want to add them or maybe append them to my table, I have complete control over there. And if I see the mismatched records, I see the mismatched records is primarily most likely due to an encoding issue. As we see, it's mostly a 50 and 5 issue right here. So if I want to fix this and if I want to add this back into the system, the application has complete tool sets for you to automate that, be it in SQL, be it in Python, Scala, or any kind of custom framework that you're working with. These are the nodes that we will be using to ensure that the pipeline that we have defined runs correctly. And the first thing that we are looking at is in terms of reconciliation, a full data comparison between the sources and targets to ensure that the data sets are being migrated correctly. Yes, if you're working with any kind of, say, transformational logic, let's say you're working with a mapping file that looks a little like this, where there are multiple source tables, including customer, sales, and geography that are being transformed into a single system with some aggregations in between, with some joining keys. The application has the capabilities of picking up this exact mapping file and creating the queries for you automatically as well. well, we are using generative AI as well to make sure that generative AI systems are actually valid. That's one of the main use cases of migration validation. The other aspect is in terms of validation of data in terms of rules and profiles. And to just illustrate that, I'll open up this example where I'm working with some incoming data set. This can be a transactional data. This could be profiling or demographic data as well. But the first thing I'm doing on it is that I'm defining rules on top of them. Now, these rules are to ensure that the data is valid both in terms of the data elements themselves, things like ensuring that there are no nulls, that there are no duplicates and so on, but also to apply any kind of business rule check that I'm working with. I'm expecting the quantity to be between certain measures. I define that. I'm expecting a particular pattern or even a precision in a particular column. I can define that. The best part here is that if I want to define my very own business rule, I can define and customize the operators accordingly. That's right. A complete part of this, which is, as you can see, zero code system. You can just drag and drop the rules that you're working with. I can just customize them to a great degree. That's not it, of course. If I want to reuse the same rules across different projects as I usually do, or maybe I would like to work them across different projects or different environments, the application can easily transfer rule sets and test cases between projects as well. Of course, that's not the only place where generative AI makes a presence within our application. If you would like to, you can actually create your very own rule sets using generative AI. So here I'll just go into wizards. What you're seeing right now is a data quality screen where we are keeping track of the data quality score of the entire system, of the model, down to a particular table to basically find out where exactly the problems comes in from. Here we see customer key is a column with the lowest data quality score. That is because the foreign key rule has failed. And this foreign key rule basically ensures that there are no orphans between any kind of parent-child relation between tables. So that's the level to which the application can do this. And just to go back to the tangent which we were on, where I would like to create any kind of data quality rule sets from, say, a generative AI system, let's use that. Data completeness rules on demographics. Let's just add that. I'll select the exact columns I'm trying to work with. This can be across tables as well. And now I'll just ask it to generate the system. So right now it's using an OpenAI system, but in our upcoming release at the end of November, we will be boxing in our very own open source LLM model as well, so that you don't even have to send anything out of your system, and we retain our compliance from that perspective as well. Right now as well, we are not sending any data out. The only thing we are sending out is the column name and the data type and any kind of context that helps them create this particular rule. And while these rules are pretty accurate, we have noticed with our research into the boxed LLM system, the custom LLM that we are building, giving some record information is going to drastically improve the quality of rules as well. And so if you are working with the system, you can just plug in the exact records that you're dealing with. You don't even have to plug it in. The application can pick it up automatically and then create the rules for that accordingly. All you have to do is just preview them and then run with it in the base system. So this is where any kind of rules that you would like to define, be it business rules, be it context specific rules, or just simple data rules, all of these can be done in an automated fashion, both in terms of creation as well as execution. Of course, we spent a good time here in terms of validation, in terms of rules, but the other aspect that I want to quickly touch base on is profile and observability. What do we mean by profile? So this comes into our data drift conversation as well, where if say we were expecting 1 million records on a daily basis, but now we are dropping down to around 500K, or maybe you've just increased it to 2 million, that in itself is a call. It's a call of an alarm, which basically states that, well, I was expecting a certain range of values, or in this case, certain profile of values, but I'm not getting that. Volume is a very easy example. Things that are going to affect a model are more in terms of the minimum maximum values of any metric, the precision of any metric, the aggregation like mean, sum, and so on and so forth. These metrics have to be kept track of day in and day out. Anytime you use your model especially, as these can exactly show you where your model and your data actually differ from one another. And for this, let me showcase an example. So here we see that, well, there's no anomaly as such, but the application is keeping track of, say, in this case, the average of the actual cost that we are working with. It goes a little up and down, but it's within the range that we are expecting, and that's perfectly fine. Let me in parallel now open an example where this is not happening. And just to show the power of the application right here, I'll be doing this on top of a BI report, just to show that the application can inherently connect with those, and of course to visualize the data itself. Here we've actually picked the output of a Tableau report just to show that this can be done from any particular data set, be it a CSV file, the output of a system, or from your BI tools as well. But here we're keeping track of multiple profiles, and it has called out an anomaly. There's an anomaly of sales right here, and the anomaly is primarily in mean. And the graph tells the entire story in a nutshell. Well, I was expecting the mean around 100 to 200K, but the mean at this point has shot up to 700K. And that is something that I was not expecting. That is beyond what I was expecting in terms of what the original data set was or how the data set has transformed as well. And that's one of the critical things, that at this point, the data set that you see, this particular screen above, the profile values, the averages, and the trends, all these themselves are data sets as well. So if you want to compare two distinct profiles, that capability is also present within the application directly. If you want to massage them further, if you want to add some traditional rules on top of your aggregations, you can do all of that and much more. Before we move on to observability, there's still a lot here. Since we discussed you need to perform any kind of analysis of the data while training as well, the application is also inherently going to define frequency analysis and pattern analysis. Frequency analysis is going to define the distribution of the data sets across different categories. And this is very helpful as an end user, especially when you're training a data set, to find out what are the categories that you're expecting, what are the categories that can be ignored, and what are the categories to look out for in terms of bias and dominance. That's why frequency analysis is very important. And while in this example, I'm working with just 3 columns, you can see in other examples, this can have quite a substantial impact. As you can see, we have a lot of quantities present here, and 550 definitely shots up there with only 2.4%, but the value itself is quite large. And so the application can actually keep track of these type of differences, and in this case, aggregations as well. And then there's of course pattern. Now pattern is very helpful when you're working with any kind of string related categorizations. Think of categorizations in terms of segregating different products into different regions or different realms, or any other kind of categorization that you do in terms of, say, you're working with demographics data, you're working with license plates and so on. So pattern analysis there can define exactly what the exact patterns that you're working with here. Here we see there's just 2 patterns, but in other systems I could find just 1 or maybe just 0. And so the application can keep track of these patterns as well. All of these are data sets, and if you want to define your very own rules on top of them, or if you want to share the results with your other team, we have the tool sets for that as well, as every run you do is saved, and you can correspondingly go back to the run history and see what the data set looked like back then versus currently. Finally, the last aspect I want to touch base on is observability, and the main reason that I opened up a Tableau report here. The reason we opened up a Tableau report is to understand visualizations. And here we have a data set that is actually visualized within the system itself. Apologies for that. Yeah. So we have a data set that's actually visualized in the system itself inherently. And now what we see is that the application that we want to keep track of is with regards to the red line, blue line, and yellow line. So what these basically represent are the number of orders done for specific categories of ship modes. Now, this same aspect of categorization can be applied to a different realm as well. Let's take pharmaceutical drugs, for example. Flu season is where you're going to have a lot of sales of flu shots. Maybe some asthma medication is something that's going to be consistent but low in volume. And there could be a lot of different types of medications which are going to follow different patterns. And that's one of the key things. Your machine learning system or your AI system is inherently going to keep track of these categorizations and it's going to have different models internally built in to keep track of this. But you as an end user should also be able to keep track if certain trends are no longer true for specific subcategories. That's one of the key things. So right now, if you look at this particular line, we see that the red line is jumping all over, and it's very volatile, but it's still periodic in nature. That's something that we have picked up. However, the blue line, while it might start much more erratic, it can stabilize itself. And the same can be said about the yellow line itself, where it has certain peaks and certain route areas. But the main aspect is, if you use just this data set to train your system will inherently define different pattern recognitions for different systems. But if something changes, say in the upcoming release or say in the next month, the blue line has also started to act erratic, or there are new jumps, or the periodic system has altered for that, that is something your model is not trained for. And so you as an end user need to keep track of this particular train change, even in terms of the categories themselves. That is where observability comes into picture. As an end user, you don't really have to do a lot of coding here. All you have to do is define your categories, define the measures to look out for. If you have some cadence-based columns, you can define them. This is, however, completely optional. And then choose the kind of prediction method that you're working with. Time series is particularly good for periodic systems. IQR and standard deviation also work fine for any other type of data set as well. And then what the application is going to do is, of course, first understand for specific data sets what you're trying to find, and then keep track of the pattern. So here, if we see that we are opening this for delivery truck, we are expecting a consistent-ish value, and the application captures that more or less. We were expecting a consistent value, and the application has done that. No worries here. A few anomalies were found in the past, but those have been adjusted. However, if I go into regular air, the story is a little different. Firstly, you will notice that this graph is quite different from the other graph that we were noticing, because different categories implies different patterns. Now, if we move from left to right, we'll see two things. Firstly, that the confidence interval is actually shrinking because we are more confident of the actual value itself. That's why the upper and lower bounds are shrinking. But the other thing is that there's a rise and fall in this pattern. We have a rise and then a fall and then a rise again. And the main reason for this is that the application understands that the data set we are dealing with is periodic in nature. That's one of the key things. And here we were expecting a value high at 336 right here, and this was on 23rd March. But this value high came of 371 and 27th March. And that's the key difference and the anomaly that the application has caught, which could signify that at this point, the periodic nature that we were expecting might be slowing down, might be dampening. Now, instead of, say, every week being a rise and fall, now we're reaching around 2 weeks rise and fall. And your model in itself should be reminded of this or should be retrained on this, because for your model, the cadence of, say, the frequency of this rise and fall was about 1 week, but now it has started to alter. And this is where the retraining process and the output analysis is quite critical, because sure, while on a surface level, everything might look fine, once you look into the deep categorizations that you're trying to work and predict, it's very important for you to find these anomalies as well. So that's a kind of hint on what the application does. This is just a tip of the iceberg. There's a lot of use cases, as you can imagine, a lot of varied systems that the application has worked with. And recently, we have also worked with a client specifically on helping them do quality assurance on their AI systems as well. So that's been a great kind of conduct for us as well, and great learning on a lot of other aspects as well. And of course, there's a lot of things that the application inherently supports, like horizontal scalability, the ability to adapt your existing custom framework, and a lot more. But with that, what I would like to do is kind of close this call. Let me quickly open up my PPT again. All right. And the final thing that I wanted to quickly, bring up is that, well, what Datagaps here is going to do is that once you define all of these rule sets within the application, it's going to create the reports for you automatically. It's going to define alerts for you. It's going to pause pipelines if needed for you. And you get to choose if you're going to move ahead to the next step or not. And it's not just a manual choosing. It's something that you can automate as well based on data quality scores. That is something that a lot of our clients have done in the past, which is that before running their existing pipelines, they actually run quality validation scores. And if the application gives them a bad quality, they push them to a reconciliation or a different pipeline. And then they put their proper analysis pipeline on top of it to ensure that the analysis pipeline is not running twice, as it can be very expensive to run such type of models or pipelines. So yeah, that in a nutshell is the extent of what we wanted to cover today. I would like to thank everyone for their patience and time, and of course the pace at which we cover all of these use cases. But at this point, I would like to see if there are any questions and any other aspects that we want to cover.
Sure. So thank you everyone for joining the webinar, and Shubhanshu for in-depth understanding of how DataOps Suite could help improve data quality for AI. So I would also like to ask attendees that if they have any queries related to the concept, they can put down their queries in Q&A section. So first question, we have two queries. So first question is, how can DataOps practices is helping organizations establish a culture of data quality within their AI initiatives?
Yeah, well, it depends entirely on kind of taking care of the upper management there, right? We need to ensure that the upper management is in on the data quality wagon, and that's something that if you ever worked in data engineering, you have to convince upper management that, well, we need a solution, either a custom framework or an outside solution to ensure that the data sets we are dealing with are accurate. Because as a data engineer, many times your task is just to fix the current leak, fix the current problem as such. So to establish a culture of data quality, we need to hit them with the hard facts. We need to tell them that, hey, this is the cost, this is the time cost, and this is the actual dollar value of, well, not fixing this issue in an automated fashion, not having a framework. Data quality is very important, and to establish a culture of data quality, we need to show them that, yes, now that we have adopted this framework, we see the improvement in terms of the fact that data engineers can now spend their time actually working on the next pipeline or improving the pipeline as a whole, as opposed to just fixing the issues of that week. And of course, from the BI perspective as well, BI and AI perspective, where they can actually have trust in the output of their BI tools and the data sources as well. It only takes one end user or one customer to say that, well, these numbers don't look right. And then the entire pipeline can, come under scrutiny on that front. And so there's a lot of rework that happens. So the actual steps to define practices is firstly to have a self culture that, yes, we need to do this, and the reason to do this is for cost saving purposes, time saving purposes, and of course to build trust. These three things are what we need to convince everyone in the firm or any stakeholder that this is what we need data quality for. And that's usually something that has led a lot of firms to change their approach towards data quality.
Okay. Thanks, Shubhanshu. Next question is, what are the best practices for implementing data quality initiatives in large-scale AI projects?
Well, if we are talking about large-scale AI projects, then the one thing I would definitely harken back to in the previous diagrams, which was perform validations on every step. If you're migrating systems, perform validation there. If you have performing some transformations, perform some validation there as well. The sheer scope of large-scale AI projects runs in billions and billions of records, and you can't really afford to rerun the model or in terms of training, or just rerun the model in terms of usage multiple times. It's going to incur a huge amount of cost and technical debt as an end user. So the only thing I would define there in terms of best practices is to have good documentation and of course perform validations on every step, as opposed to performing validation on just a couple of steps and hoping that anything else doesn't go wrong. So I would say the best practice there is to perform validation on every step.
Right. So with that, these are the two queries we had. And if you have any more queries or use case to discuss, you can always drop a note at contact@datagaps.com. That's the mail ID we have already shared on screen. Okay. Thanks a lot, Subhanshu, again.
Yes, thanks you. And if there's anything specific that you would like to discuss with us, feel free to contact us at datagaps.com.